Remember, sometimes it's easier to solve a logarithmic equation if you change it to an exponential equation. So to solve log base 36 of x equals 3/2, we're going to change that to an exponential equation by rewriting it as the base of the log is the base of the exponent, so 36. The power is the 3/2, and that's going to equal x. So what is 36 to the 3/2 power? Well, you could easily do that in your calculator, but just to remind you what a fraction power means, the top number is the power, and the bottom number is the root. So 36 to the 3/2 power means the square root of 36, and then take that to the third power. So what's the square root of 36? Well, the square root of 36 is 6, and then 6 to the third power is 216. So that's one way to do that without the use of a calculator. These two questions are logarithmic equations, and just like with exponential equations, if they're in the same base of an exponential equation, if they're the same base logarithms, then we could just set what we're taking the logs of equal to each other. So since this is both log base 2's, we could just simply set x squared minus 4 equal to 3x. Now don't think of it as the logs canceling each other out. That's not what is happening. It's just since they're both log base 2's, they're both same bases, what we're taking the logs of must also equal each other. So how do we solve x squared minus 4 equals 3x? Well, since it's x squared, it is a quadratic equation, and most oftentimes to solve a quadratic equation, we need to have it set equal to 0. So I'm going to add 3x, excuse me, not add. I'm going to subtract 3x from both sides. There we go. Subtract 3x from both sides. So that'll give me x squared minus 3x minus 4 equals 0. And this is factorable. Of course, if it's not factorable, we should use quadratic formula. So factors of -4 that add up to -3 would be -4 and +1. So just to remind you, that gives you -4x on the insides, +1x on the outsides, and those two add up to the -3x in the middle, so that's how we would check it. And since it does check out, then we will set each part equal to 0. So x minus 4 equals 0, and x plus 1 equals 0. And so x equals 4, and x equals -1. So remember, what that literally means is that we should be able to plug in 4 in for the x and plug in -1 in for the x, and we should get true sentences. So just to show you, just to check, does the log base 2 of 4 squared minus 4, does that equal log base 2 of 3 times 4? And 4 squared minus 4, 4 squared is 16, minus 4 is 12, so that would be log base 2 of 12. And 3 times 4 is 12, so that would be log base 2 of 12, so it checks out. And if it's a real solution, it should also check out with the -1. So let's check that one. So is the log base 2 of -1 squared minus 4, does that equal log base 2 of 3 times -1? Well, on the surface, it looks like it does. We would have log base 2 of -1 squared is +1, 1 minus 4 is -3, so that would be log base 2 of -3. And this side would also read log base 2 of -3, so it looks like it would work out, except what do we know about taking the logs of a negative number? We know that that's impossible. You can't take the log of a negative number, because remember, this literally means 2 to what power equals -3. And there 2 to no power will ever equal -3. So that means that negative 1 is actually not a solution. So I'm going to cross that out. X equals negative 1 is not a solution, and there is only one real solution, and that is x equals 4. So with logarithmic equations, you are going to have to check your answers and see if the answers truly work with the original logarithmic equation. Sometimes they both work, sometimes neither of them work, sometimes one works and the other one doesn't. Don't fall into the trap just thinking that negative answers won't work. Sometimes the negative answers actually do work. Let's try another one of those. So this one is similar to the other one. Log base 3 of x squared minus 15 equals log base 3 of 2x. Since they are both logs of the same base, we can just set those parts equal to each other. So x squared minus 15 should equal 2x. And it is also a quadratic equation, so I will set it equal to 0. So x squared minus 2x minus 15 equals 0. And then that is factorable. It factors into x minus 5 and x plus 3. They multiply to be negative 15 and they add to be negative 2x. Set the parts equal to 0. So x would equal positive 5 and x would equal negative 3. So does that really work with the original problem? So going back to the original problem, log base 3 of, if I replace the x with a 5 to the third power minus 15, does that really equal log base 3 of 2 times, and we figured out that x equals 5. Is that true or not? Well, 5 to the third power, excuse me, that shouldn't be 5 to the third power, it's 5 to the second power. Not sure where I got the third power. So 5 to the second power minus 15, 5 squared is 25, minus 15 is 10, so log base 3 of 10. Does that equal log base 3 of 2 times 5, which is also 10? So yes, that is true. We get positive 10 that we're taking the log of, so that is part of the domain, and so 5 is an actual solution. What about the other one? Does the log base 3 of negative 3 squared minus 15, does that really equal log base 3 of negative 2 times negative 3? So negative 3 squared is 9. 9 minus 15 is negative 6. And quite frankly, I can stop right there because I can't take the log of a negative number, even though it does seem to give you negative 6 on the other side. But again, we can't take the log of a negative number. So negative 3 is not a real solution, so I'll cross that out. And my only real solution is the x equals 5. There is a name for a solution that you get that does not work with the original problem. It's called an extraneous solution. So if you ever hear me say extraneous, it means that it is a solution that we came up with, but it does not fit the original problem.